The problem is que I super focusing in the mathematical part. Okay, so now in the right hand side we have 84 plus 60 get 144. Okay, so for x divided by 9, x squared is 144 divided by 9. You apply square root both sides. It's plus or minus, don't forget double sign. Plus or minus is 12 over 3. But 12 over 3 is 4, so it's plus or minus 4. So we have two possibilities of the solution of x. Okay, let's say we have, I suppose, two possibilities, or I don't know, say one possibility of y. And of course, we have 4-point solution. I guess so. I don't know. So now, to find the y value, you take the easier equation. In my opinion, is this equation. You suppose you can use it either. However, you replace x for plus or minus. I recommend using double sign. Why? Because when you square, become positive. So it's the same answer. This repetition. Again, no. Minus y squared equal 12. This is 16. It doesn't matter, get positive or negative, 16. And 16 minus y squared equal 12. Okay, therefore y squared is equal to 16. 16 minus 12 is equal to y squared. And it's a 4. Equal y squared. Apply square root both sides. Y is plus or minus 2. Well, thus we have actually, we predict 4-point because for positive and negative, you get two values. Entonces, plus or minus 4, comma, plus or minus 2, no? And actually, si you break it down, different point is 4, comma 2, negative 4, comma negative 2, negative 4, comma positive 2, and positive 4, comma negative 2. It's the classical 4-point. Do you see that? Okay, verification as always in Desmos is mandatory. Double checking. Let me try. Let's see. Wow, I do not open Desmos. Let me try. I close the window. Okay. Here we go. Okay, we are doing number 16, no? Yes. Okay, let me share the screen to Desmos. Okay, there you go. You see that? Look, I copy two equations and the point, the 4 combination for the point. It's clear. We have a hyperbola. We have circle. No, not exactly circle. It's ellipse. And the intersection is 4-point. Very good or no?
That's good.
That's good. Okay. Let's move to 17. Well, 17 is in another page, no? Yes. Okay, so erase everything and download again the package. Okay, review 2. Now that page. Excellent. Okay, let me share the screen with you. Whiteboard. Okay. Do you see that? Do you see that? Okay, I want to go 17. 17 is x squared plus y squared equal 9. X squared minus y squared is equal to 9. Wow, super easy. Equation 1 and equation 2. It's easy because it's ready to elimination the y part. So you add equation 1 plus equation 2, column by column. We have 2x squared. This is cancel. And this is 18. Divided by 2. X squared equal 9. Apply square root both sides. X is equal plus or minus 3. Nice. Now I'm going to find the y value. You select either equation. I don't know why in my paper I select the second because I consider it easy. I select this. EI substitution using double sign. I take advantage que square is positive. So we have for two solutions, unique solution. Entonces plus or minus 3 square minus y square equal 9. Plus or minus 3 square is 9. Therefore, solve for y, 9 minus 9 equal y square. 9 minus 1 is 0, y is 0. No plus or minus because 0 have no sign. And in this case, you have only 2 points, 3,0 and minus 3,0. To verify that, I go to decimals. We are doing 17. 17 is two linear, non-linear equation. Look, one is a circle, the red one is circle, the second one is a hyperbola, and the intersection is 2 points, 3,0 and negative 3,0. Okay, entonces my recommendation is always doing in that way. You say, no, you solve them by end the piece of paper, right? And you double check in your answer in decimals. Okay. So far it's clear, guys? No problem. Well, the question 18, 19, and 20 are inequalities. And so my recommendation is doing in decimals, no paper, no. And you, for example, when you finish that, look, a copy, look at the format. The format is, the first inequality is 4x plus 3y greater than or equal to 12, and the second is x greater than or equal y. You copy exactly the same, no manipulation or anything. Bam, and you get that. Okay? And you get that. Okay, this is a solution. Any point inside the gray colors region is solution for this. In this case, let me see, corresponde, in my opinion, the option B, no? Option B, right?
We don't see the paper, Professor. We see decimals.
I know that you don't see, but well, okay. Let's come back. Let's come back. But you have the paper, no? You print out or you have in your computer the review package?
That was when I just opened it.
Do you think it look like C?
Yes.
Yes. Okay, let's move on to the 1920.
Professor, so how do we show this in the actual paper exam?
Well, good. You now, okay, in the actual piece of paper, you see decimal now, Mister? No.
No. It's on the
This is
whiteboard.
Yeah. You are doing this. Now you see, right?
Yeah.
Okay, you click here in which you say share the graphic. You export, and you download here in the format, and you send me this, like a one attached piece of paper.
Oh, okay, I understand.
Okay, 19 is similar. Look, 19 is a system. This system is a circle and the line. Circle and the line. Look, circle and the line. Circle and the line. Is inside the circle and below the line because it's less than. Okay. In that case, let me try to see the package. Is okay, es this. I suppose que yo select the option C, right? Well, again, let me share the screen. Okay, this one. You see? Make sense, que sí?
Yeah.
Professor, I have a question.
Mm-hmm.
For the work of 18 through 18 through 20, we just have to show the graphs.
And that's it.
And that's it? Okay.
Exactly, I explained in the other student que asked me first. So you are doing the graph in Desmos and you get the graph in Desmos and you send me attached for the solution in paper. Okay. Moving to 20. Moving to 20. This is easy, super easy. I told you this test is easy. The only complicated part maybe is the linear programming, but I want to explain in detail now. Okay, let's move on to the Desmos again. Let me share the screen for the Desmos. Okay. Okay, now 20. Now 20 is, again, it's a circle, center and the origin, and radius 9. And this is a line. It says inside the circle and below the line. It's very, very, very similar. Very, very similar. You want to show step by step, you can show step by step. Look, let me how. Curiosity. You, for example, you copy that. Control C. Control X. Good. And Control B. Of course, you remove do you see in the same color is better to see the circle is inside the circle is logical because it's less than, and this is the line is below the line, and the coincidence in between the circle and the line is the part you see like a dart. Okay, it's a coincidence. This part no, this part of course no, this part of course no, is that part, the solution. One elegant way to do this is you now take this, Control X, open the famous curly bracket, Control B, and you put together and delete this line. Good? And remember, miss, you click here, share the graphic, export like an image. And you select here, you do experimentation here, medium, hard, I don't know, think, and different format. A square bigger, rectangle medium, I don't know. I never see before this. But one good image is okay. No problema.
No problem.
No problem. Okay, let's come back now to the 21 and 22, guess the last questions. It's basic linear programming. Okay, linear programming. It's the last page. Remember, linear programming consists in two pieces. We have, okay, this one. Linear programming, we have one objective function, que es the function that you want to optimize. Optimize means, do you see the whiteboard or no? No?
No.
Okay.
No.
Okay. Let me try. Okay. You see now, right? Do you see now?
We see it.
Yeah.
Okay, in the test, you have no word problem because the challenge and the complicated part is read the problem, understand the word problem, set out the equations. It's the hard part. No. The equation is given, and you not only apply the technique for solving this problem. This is a typical problem of the optimizations. We have the objective function, que es the function that you need to optimize. Optimize means minimize or maximize, depending on the problem. This is objective function. And separately to objective function, we have the constraints. The constraint in this problem is 0 and between x and 10. Y and between also 0 and 5. And 3x plus 2y greater than or equal to 6. This is the inequality, system of inequality that represent the constraints. Okay, this constraint generate one specific figure that you see now. We can do by hand, but no. Suppose that I did before, I have in my paper, look like that. Something like that. Immediately, in a few seconds, you see how you form this, and you get the feasible ratio. So at any point inside this polygon, satisfy perfectly this inequality. Because I suppose that this level is 10, is a y, this level is 5. So this two constraint is the square, and this constraint is the line that travel in this direction and touch in this point. By the way, I know that this is 2 and this is 3. Let me see how do you see that. There are many ways to see it. And this corner is obvio que es 5,10, ¿no? O 10,5, no? 10,5. I make a mistake. This is 10. Hello. This is 10. This is 5 because y is 5. But this is 5. This is 10. And this is the famous point 10,5. The basic we have 1, 2, 3, 4, and 5 because we have 1, 2, 3, 4, and 5 sides. We have pentagon. And you evaluate the objective function one by one into this point. And you determine que es maximum at this point. You determine one by one, plugging in. So you want, let's do it now. It's super easy. The maximum value is 215 that occur at x equal 10 and y equal 5. So basically, the procedure is number one step. You open decimals. You put it the inequality system similar to the other example we are doing. You determine the feasible region. Feasible is the real que satisfy our restriction, our constraints. Outside have no sense. Stupid. My solution is inside. However, any point inside is not optimal. It's optimal the corner because they normally the linear programming, this is a line, and the line when it touch the first time, the polygon maybe is here, depending on the inclination. No, see the line is like that, doesn't touch in this point. But in this case, no. Okay, touch this first. Let me explain. Suppose que yo evalúe z at 2,0, que es that corner. Yo evalúe z en 0,3. Yo evalúe c en 0,5. And you evaluate c en 10,5. And you evaluate c en 10,0. Okay. Entonces, sí, es 15 times 2 plus 13 times 0. Es 30. Es 15 times 0 plus 13 times 3. Es 39. And the rest is 15 times 0 plus 13 times 5 is 65. And you see, wow, increasing. But I need to find the maximum. So this is 15 times 10 plus 13 times 5. Okay, it's 150 and 65, 250. And this is 15 times 10 plus 13 times 0 is 150. It's obvious that this is the maximum. And this, okay. The optimization problem contains two answers. The maximum value of this objective function is 215, and this occur at x equal 10 and y equal 5. I don't know, suppose que x is the orange and y is grapefruit. The optimal profit, I don't know, is 10 orange and 5 grapefruit. Okay, something like that. You understand the idea? Pero no. Let's move on to decimal to see visualization in one countable and easy way, the feasible region, and now the rest is piece. Okay. Okay. Let me try. Do you see or no the decimals? Do you see? Yes or no?
We see.
Okay, entonces I copy. Remember, I copy any equation of the constraint separated by curly bracket. Because both curly bracket indicate us in decimals, language, and intersection. If you copy one inequality, intersection. Entonces, in my opinion, no, the easy way is put together, okay, you see the feasible region, look. That part is not important now. And determine immediately, graphically, easy, what is the corner of this polygon? Pentagon. Okay, and now you evaluate the objective function in each corner and you determine the maximum. One, graphical and clear way, in my opinion, is you copy the objective function 15x plus 13y equals z, you declare z, and see you create one slider. It's super easy to create a slider because you put c equals something, automatically let's create a slider. Yeah, I can see that you can move the slider here or here. And do you see specifically in this corner, so the first corner que touch, this is the huge value, 300. And when you decreasing, this is not feasible. This is impossible solution. This is a possible solution. But the first time it's possible, the solution is in that corner. It's exactly 250. End the story. Do you understand very well or no?
Yes, it's very easy.
Yes, and this is the way I want to see in the test. You compute by hand, of course, the value in the piece of paper. Huh? But the solution for the inequality and determine the feasible ratio, you are doing using decimals. And this is totally complementary. The line que move with the slider, no. Si you like, you can, but if you don't like, not necessary. Because basically, I did by hand. I determine that the maximum value is 215 at x equal 10 and y equal 5. Wow. Any question? No?
So we attach the decimals image, and then we also show the work that we did for this question.
Yeah. You show me only the evaluation for objective function in the corner. So, okay, the procedure is number 1. Do the solution of the constraints. Constraint is a system of inequality. In linear programming, always is linear. No circle, no ellipse, no hyperbola, no. It's linear. Linear is line, vertical line, horizontal line. So this look like polygon. How many sides depending the problem, no? Now you determine the corner, and the corner is the potential point when there is optimization. You evaluate the objective function and the value for each corner, and you determine what's the maximum or the minimum, depending on the question. So it's maximum or minimum. Another question, guys. Okay, let's move into the last question. Last is, let's see, last page. Last page. Okay. Okay. Let me share the whiteboard. Do you see?
Yes.
Okay, as usual, I am solving the system. So I exclude the objective function. No participate in this game now. I focus on the objective function and the constraint, sorry. Yeah, I try to do the graph of the constraint. Of course, in decimals. I know the answer. Well, the first two constraints, x greater than or equal to 0 and y equal to 0, represent the first quadrant. And normally this happens because in the real life, the majority of quantity is positive. When you're talking about orange, truck, tree, apple, it's positive, no? Negative apple have no sense, no? So the solution is located. Now we have two lines, this line and this line. You put together, approximately, I know the solution is something like that. Okay, and this is my famous feasible ratio. How you can determine this corner? Well, there are many ways to do that. Analytically, this is the solution. So you consider like equation, for example, 2x plus 3y equal 12, and 2x plus y equal 8, and you intersect and you solve in this system, you get that point. You get that point, and this point is the point 3,2. Entonces now, for example, this point is 4,0, que es the x-unit set of this line. Okay, this line is this line. And this point is the y-intercept of the other line, que es 0,4. The y-intercept of this. When you solve for y, and this is 0, 0. And this is our feasible region, and this is a polygon. And I need to evaluate the objective function inside each corner. So C evaluate 0, 0 is obvious 0, no? Because 6 times 0 plus 7 times 0. it's 0. This is the corner. We don't have no sense. No, all we have in the lower corner don't know participate. Depending if it's minimum or if it's maximum. Okay, the next is 0,4. Entonces 6 times 0 plus 7 times 4 is 28. Evaluating the next corner, que es 3,4, is 6 times 3 plus 7 times 2. This is 18, this is 14, this is 32. And finally, 4,0 is 6 times 4 plus 7 times 0 is 24. Entonces es obvio que the maximum is in 32 here. And you see, what is the optimum value? The optimum value is maximum 32. Look here, like the option B maximum 32 at 3,2 is this. Sorry, not this. Okay. Do you understand very well this?
Yes.
Let's see decimal, and that's it. This is the classical example you see in the test. No, in the test online, no, sorry, I put the hard work problem. I don't know, see Mr. Amore, you are there or no?
I'm here.
You understand very well the problem I said in the solution or no?
Yes, I got it wrong.
It's
the
wrong.
answer you said was wrong. It was wrong,
Really?
and then I realized it was something else.
Entonces, bueno, we need to discuss it. So my answer is wrong.
Yes, but
Wow.
the right answer was in your work.
Okay. Okay. Yeah, I forgot. When I save, I take a screenshot for the first one, but I don't know where I save. Entonces now, can you send me? I redo again. Okay.
Okay, I'll send it to you.
Okay, let's move into this one now. Do you see Desmos? Do you see or no?
We should.
Yeah, question 22 now. No, look at the system. Oh, look at that. This is my feasible region. In this case, super easy. And the majority of problem is easy. You don't need to simultaneously the equation. You see clear here. Wow, that corner is 3,2. This corner is 0,0, this corner is 4, and this corner is 4. This is my feasible region. My objective function is a line. Okay. This is impossible solution. This is possible solution, but not optimal. The optimal is when it's maximum or minimum. Suppose que it's minimum, it's here, minimum. But it's maximum here. Okay, the answer was 32. Done? Okay. Super clear?
Very clear.
Okay. That's it, guys. We finish. We see. So now, let me clarify something. I sent in this email the copy for you of the written test, no? Que es due March 1st. So next Tuesday. It's okay? And next Tuesday is also due the test number 2.
Yeah, I say yes.
Okay. And is this day, March 1st, is also due the test number 2 online analysis, correct? Any problem you have, you need to communicate with me by email, and we negotiate something, okay? This is not for general students, no? In particular student, have situation, professor, irrelevant issue, I don't know. See, do we have no problem? No. That's it, end of story. Because next Tuesday we start a new chapter, and that's it. By the way, super interesting. Okay? Any question? Are you clear?
I have one question, but it isn't about this exam. It's about the final. The final, another student of us, or in the class, I don't remember their name, they told me that it wasn't optional. It's optional.
Yeah, you are right. The final and this subject is totally optional. You take if you want to improve. Otherwise, no. Suppose you get 100, 100, 100, A, and for tests, you get A in the overall grade. Suppose you get some B, some C, and when I compute, your overall grade is, suppose 86. 86, I put B like a final. To say, no. I don't want B, I want A. I want to take the test. What is the problem? You suppose you take the test and you fail the test. No, nothing changed. You stay with the 86 and it's B. And so you improve, go up. So you screw up, you are doing a mess. And the final test stay the same. So only a solution for the student improve. Okay?
Awesome. Thank you, Professor. Have a great day.
Another question? No question? So bye-bye.
Have a good day, Professor.
You too.
Thank you.
Mm-hmm.